All right, we're going to try this out. This is section 5.1. All right, and we're doing example 5.1, and it says to find the equation of the line tangent to x squared plus y squared equals 25 at the coordinate 4, 3. And we're going to use old techniques to do this. Okay, we don't know how to do it with implicit differentiation yet, which we will do in a minute. We're going to do what we already know how to do from chapter 4. Okay, so what we're going to do is solve for y first. Okay, so we're going to do y squared equals 25 minus x squared, and y equals plus minus the square root of 25 minus x squared. Okay, so we have two different roots. We have f1, which is the positive square root of 25 minus x squared, and we have f2, which is the negative square root of 25 minus x squared. Okay, and we're only going to use one that we're going to take the derivative of. Okay, so if we're going to take the derivative of one, it's a little easier to take the positive one. Okay, and in order to take the derivative of the positive one, we have to rewrite it. Okay, so f of x equals 25 minus x squared to the 1/2. And we're going to use the chain rule to take the derivative. So f prime equals 1/2 times 25 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. All right, so we don't have to rewrite this like I asked you to do in chapter 4, but we do have to plug in the coordinate 4. So we did this a little bit in chapter 4 where I asked you to plug it in because we're finding the equation of the line tangent. We just didn't really talk about it very much. So I'm going to put the coordinate 4 in, okay, for the x coordinate, because that's the only thing we have right now. So f prime at 4 equals 1/2 25 minus 4 squared to the negative 1/2 times negative 2 times 4. We're going to simplify. 1/2, oops, sorry, kind of a little bit off. 25 minus 8 to the negative 1/2 times negative 8. 1/2 times, 4 squared is actually 16, so we all make mistakes. So sorry, that's 16, so I get 9 to the negative 1/2 times negative 8. 1/2 times, now I'm going to flip it, so I get 1/9 to the positive 1/2 times negative 8. Okay, and at any point in time, you could type it into the calculator, but I've been finding out that my calculator isn't that reliable. It's been giving me weird answers. Okay, So 1/2 times the square root of 1/9 times -8 is 1/2 times 1/3 times -8, which simplifies to, sorry, getting used to the screen, a -4/3. Okay, and I could write the equation with that. So I could write y minus 3 equals -4/3 x minus 4. Okay, so there is a new way to do it. Okay, and it's called implicit differentiation, and it's a lot easier. And we're going to use the notation dy over dx. So in chapter 4, we said we would take derivatives using dx of f of x. Well, now we're going to use, so B asks us to do dy dx of the same equation, the original one, x squared plus y squared equals 25. Okay, and what happens here is that I'm going to take the derivative of each piece. So let me take the derivative of each piece, and I get 2x, and I get 2y, and I get 0. Okay, but because I'm doing dy dx instead of d dx, and I essentially need to distribute that to all three parts, I'm going to need to attach dy dx to every time that I take the derivative of y. Okay, so I need to make sure dy dx goes with the second term. Okay, I also like to think of it as if there's an x on the bottom and I'm taking the derivative of x, then they cancel out, kind of like a multiplication cancelization. Okay, so either you can think if I take the derivative of y and y is on the top, then it has to stay, or then they cancel out. Okay, so what I'm going to do now is I'm going to solve for dy dx. So I'm going to subtract 2x. So I have 2y dy over dx. And I'm going to divide by 2y. So dy over dx equals -2x over 2y, which simplifies to -x over y. And you're like, hey, this doesn't match what happened up here on part A. I need that -4/3. Well, remember my at 4, 3. So I'm going to plug in 4 and 3 for x and y. So I get -4 over 3. And I can plug it into my equation up here and get the equation. Okay, we're not going to worry about plugging them into equations of the line tangent. We're just going to be worried about solving for dy dx from here on out. Okay, so we're going to do another one. Okay, we're going to do a total of 3 more today, and we'll do some more on Wednesday's lesson. All right, so here's the equation here. We're going to do example 512, and it's 10p plus 2pq plus q squared equals 1,000. Okay, and it's going to ask us to find dp dq. Okay, so a lot of what we're going to do is going to be finding dy dx or dp dq. We'll occasionally find a few others, but a lot of dy dx, dp dq, that's how we're going to do it. Okay, so we're still going to have to find the derivative of everything. And I like to write my first line with dp dq on the outside of the equation. So I'm going to put dp dq 10p plus 2pq plus q squared equals 1,000. Okay? And what I'm going to do from here, again, is I'm going to take the derivative of everything. But when I take the derivative of q, I don't need to attach dp dq onto it. And I do need to worry about right here, I have the product rule. So I mentioned in chapter 4 that we were going to have to worry about the product rule quite a bit in this chapter. And this is where it's at right here. Okay? So we'll talk about that here in a second. So the derivative of 10p is 10. And I'm taking the derivative of p. So when I take the derivative of p, I need to attach dp dq. Plus, here's my quotient rule. So I like to say, let's put it in the margin where f is 2p and g is q. So we're going to separate the pieces of the quotient rule and we're going to see them on the side. Okay, so I'm going to take the derivative here. Remember, I'm going to do f prime g first. So the derivative of 2p is 2. And I'm going to do q stays the same. And I took the derivative of p. So I do need a 2p, or sorry, a dp dq. Plus, now I need to do the other half of the quotient rule, which again is fg prime. So 2p stays the same, and the derivative of g is 1. So you can put a 1 there as a placeholder, but I'm going to just leave it out. And because I took the derivative of q, I don't need dp dq. Remember, they kind of cancel out. Plus 2q, which again, I took the derivative of q, so I don't need to put a dp dq equals 0. This is the hardest line. So even though there's a p in the answer, I did take the derivative of q. So I need to leave it alone. Okay, so it does not need the dp dq. Now I'm going to solve for dp dq. So what I do is I take the two terms that do not have dp dq and I subtract them to the other side. So I like to put them both with negative signs. But you could also write it as a negative parentheses 2p plus 2q. Either way is acceptable. Again, you'll see me write it as two negatives. So whatever you want to do is fine. On the left side, we're going to factor out dp dq. And we get 10 plus 2q. So a note here that I like to tell students is, at this point, you shouldn't be able to add or subtract any terms. Everything should be all individual terms. So what I mean here is I shouldn't be able to add 10 to 2q. They're different terms. They don't have the same tails. And on the right side, same thing. I shouldn't have anything where I can combine values. So they're different tails. I don't have p's and q's, or I mean I have p's and q's. I don't have two q's as tails to combine them, okay? So now I'm going to take my left side here and I'm going to divide it to the other side. So I'm going to get dp dq, and I'm going to get a negative 2p minus 2q over 10 plus 2q, okay? And WebWork is likely to accept that, but if it were to happen on a quiz or a test, I would ask you to simplify that. So each piece is a multiple of 2. Okay, if 3 of the 4 pieces are multiples of 2 and the other is not, then you leave it alone. But all 4 are multiples of 2. So I'm going to ask you to make this negative p minus q over 5 plus q. That's your final answer here. Okay, So make sure if you don't understand any of this to hit me up with any questions on Monday, okay? All right. So another one that's similar to that one, okay? So we're gonna do example 513, which is the following. Here, let me write it up here. 5p plus 3pq to the 1.5 plus 2q equals 2,000. And we're going to find dp dq. Okay. So the book does this slightly differently than I do. Okay, so the way the book does it, I think, is a little bit tricky. So what I like to do is to distribute that 1.5 to both the P and the Q. And I think it makes it a little bit easier to work this problem out. So I'm going to put my dp/dq on the outside like I like to do. And I'm going to distribute that 1.5 to both pieces. Okay. And I'm going to, again, take the derivative of everything. And just like the last one, I'm going to take, I'm going to only leave dp/dq when I take the derivatives of p. And they're going to cancel out every time I take the derivative of q. So I'm going to start with the first term, take the derivative of 5p, and I get 5. And because I took the derivative of p, I'm going to get a dp/dq. It stays there. Okay. On the next part, again, I'm going to put it in the margin. My f on the product rule is 3p to the 1.5. And my g is q to the 1.5. So it's a little easier to see it when it's not in line. So I'm going to take 3p to the 1.5. I'm going to take the derivative. So the 1.5 comes down, times 3 is 4.5. P, I'm going to subtract 1 from 1.5 to get me 0.5. G is going to stay the same, so I get q to the 1.5. And I took the derivative of p, so I get dp/dq. Okay. Now I have to do fg prime. And I'm going to write it out exactly like most of my students do. So they give me 3p to the 1.5 because it stays the same. And then when they take the derivative of g, they put 1.5 times q to the 0.5. And because I took the derivative of g, or the derivative, of g, or the derivative of q, I don't need dp/dq. And now I need to take the derivative of 2q, and I get 2. And I took the derivative of q, so I don't need a dp/dq, and I get an equals 0 on the right. Okay, so I'm going to show you in a minute how to fix this 3 and the 1.5 and rearrange the terms. Okay, I'm going to expect you to fix that. So what I want to do here is, again, I'm going to do the same thing that I did in example 2. I'm going to move the two terms without dp/dq to the right side. So I'm going to subtract this piece here. Okay, so I'm going to take 3 times 1.5. These are all multiplied. So I'm going to get negative 4.5. Don't forget I subtracted it right and I multiplied it. I'm going to get p 1.5, q 0.5. And this plus 2 becomes a minus 2 because I moved it right. On the left side, I'm going to take dp, dq, and I'm going to factor this out. 5 plus, I hope I left enough space, 4.5, p 0.5, q 1.5. All right, squeeze it in. And again, I'm going to divide as the last step. So dp dq equals negative 4.5 p 1.5 q 0.5 minus 2 over 5 plus 4.5 p to the positive 0.5 q to the positive 1.5. And that's my, oops, sorry that you guys couldn't see that. That's my very messy answer. Okay. So this one's a little bit trickier because of the decimals, but similar to the one before, and it's going to bridge us into the very last problem. Okay, so we got one more today, which is example 514, and it reads 0 equals 50, L to the 0.75, K to the 0.25, and we're gonna find DL, DK. Okay, this problem is a pretty famous problem, at least in terms of implicit differentiation in calculus. It's called the Cobb-Douglas problem. We'll see it again, and a lot of students, when I have them in the classroom, kind of groan about it. They really don't like this problem, okay? Because maybe they didn't figure it out the first time we did it. And the other hard part now for you is that you're gonna have to show all the steps when you guys take the quiz and take the test. So there's no skipping steps around and things like that. So this problem does become quite difficult if you don't do it the right way. Okay, so there is a way that the textbook shows you to do it, and there's a way that I will show you to do it. My way is a little bit easier. So sometimes that happens where I show you a slightly easier way than the textbook shows you, okay? So what I'm going to do that's different than the textbook is they leave the 50 on the right side. Well, you don't have to do that. In the end, the problem actually remains the same if you remove the 50. So we're going to take 0 over 50. And again, I'm going to put my DL/DK next to my problem. I get L 0.75, K 0.25, and we're going to take DL/DK. Okay, so I'm going to get 0 on the left when I take the derivative. Otherwise, the way that it was in the first line is it's written as a scalar. So it's going to then become complicated because you're going to multiply things. And a lot of my students get confused when they leave it in. So what we're going to do here is we're going to take, here's our product rule. Here's F and here's G. So in the first one, I'm going to take 0.75 down. And when I subtract 1, I get negative 0.25. And K stays the same. And then I need to decide, do I keep or get rid of DL/DK? Well, I took the derivative of the L. Okay, and L is on the top, or if you want to think of, did I cancel K out? Well, I didn't take the derivative of K, so I need DL/DK. Plus, here I'm going to take the derivative of K. So again, I'm going to show you what a lot of students do. They write L 0.75, they write 0.25, and they write K negative 0.75. Sorry, let me move this over. Okay, and so they put the 0.25 in the middle, and again, that's okay for right now. So we'll leave it in the middle. One of the hallmarks of this problem, if you do it right, is that here you have the minus and here's the plus of the same number. So they're opposites. And on this one, here's the plus and here's the minus. So again, they're opposites. Okay. And the second part of this problem doesn't need a DL/DK because we took the derivative of K. And again, they would cancel out. So only one of the two needs a DL/DK. Just make sure you put it on the right one. So we're going to move the one without DL/DK to the left side. So I'm going to subtract the second term. So I'm going to get a negative. And I like to here at this point move the constant to the front, negative 0.25, L to the 0.75, K to the negative 0.75 equals, I'm going to leave the other term alone, 0.75, L negative 0.25, K 0.25, dl over dk. Sorry about that. Okay. So we have that problem. And then we're going to divide. Okay, again, we want to solve for dl dk. So here, to make my life easier, especially if I'm working left to right, and I'm writing pretty big here, but like on a worksheet that we would have had in class, or if you're one to print them off, you could easily print it off at your house if you want. I like to move dl dk all the way to the left. Okay, because we're going to equal it regardless. Just make sure that you're dividing by 0.75. Okay, that one's the one on the bottom. So I get negative 0.25, L 0.75, K negative 0.75 over, sorry, I kind of crossed through that K, 0.75, L negative 0.25, K 0.25. Okay, so now I have a little more room and I can keep working right rather than having to keep working down and take up a lot of space. Now, if you write big, don't worry about it. Just keep writing straight down, no big deal. Okay, so what I need to do here, and I happen to have a red expo marker right here, is look right here. I have a red, and I have two negatives. Well, I can't have those, just like I could in the last chapter. So I need to get rid of them. And the easiest way to do that is to take this term that has the negative and move it down, and take this term that has the negative and move it up. So I'm going to have a negative 0.25. The L to the 0.75 stays. And my L to the negative 0.25 moves up, but drops the negative sign. Over 0.75. And I have K to the 0.25 stays. And that K to the negative 0.75 moves down and drops the negative. Okay, so I have one more step you absolutely have to do, and that's we need to combine the L's and we need to combine the K's. Okay, so they can be added together. So we're going to get a negative 0.25, and we get L because 0.75 plus 0.25 is L, just L to the first. And we get a 0.75 over K to the 0.25, K to the 0.75 is K. All right, so you can leave it like this, and you'll see in the textbook, and I don't think you'll have a problem in web work, but you do need to make this simplified. So 0.75 over 0.25 over 0.75, especially if you know a lot about American money, think about it in terms of quarters. Well, this is 1/4 to 3/4. So this is a negative 1L or negative L over 3K. So if you can simplify it, great. If you make an accident when you're simplifying it and it doesn't simplify right, I go back and I look at this part and make sure that you did that correctly. Okay, but you do need to show all the work. So you need to show, hey, I took the derivatives, the implicit differentiations on the right piece. I need to show that I subtracted. I need to show the division. I need to show that I knew how to move things side to side, all of those pieces. Okay, so on Wednesday's lesson, we're going to do more of the same. Okay, this is a little bit tricky for students to learn in just one lesson unless they've had it before. Okay, so if you want to, you can start on the web work. Okay, or I recommend to do the odd problems. You'll have to look it up on the book reading outlines. So remember, those are available. Book reading outlines. So the book reading outlines has some odd problems from the textbook. So you might want to work through those if you have time to get there.
Hello.